So this particular item is somewhat similar to what we just did in a way, except it's going to have a lot more sort of like randomizers in the data. And the way that you sort of push and pull things in and out changes. I'm going to try and keep it as simple as possible. Let me turn that stuff off. And I think the way I'm going to do this is just with a couple of points. So I'll kind of go like that and build circles off of those points. So let's go to param, pull in a couple points. This one's going to be top. This one's going to be bottom. Whoops. Sorry, video people, I just smacked the microphone. Yeah, sorry. Okay, so I'm going to build this off of circles, just like I did before, except what I'm going to do is, so diagrammatically, I'm going to set up a whole series of rings, right, like this, and they're all going to have points around it. Right, and then each item, right, so there's going to be a whole set of these, right? You're going to have a set that keeps going down, and if this is 0, that's 0, that's 0, each one is coming from a center point, and I'm going to move it in and out using a vector from the center point to that piece. And so each set, right, the zeros, are all going to oscillate, right? They're going to sort of move in and out based on that. So let's go to circle, put one here, one here, and radius 0 to 50 again. There we go. Oh, you know what? I don't think I want to do these circles. Let's do a line. And let's divide that line with perp frames. We'll pick how many. Something like that should do. And then we'll put circles on those. Boom, like that. So that is going to be my structure. I'm going to divide each of the circles that you're seeing. I don't know why I copied the circle thing twice, actually. So let's go to divide, so curve division. And so there we have this here. So I'm going to keep it really simple and just leave it at 10 for now. I might go back and change it a little bit later. But what's important is that we're looking at a specific column. Okay, so I'm going to go to display, vector, put that in there, 0 less than 50, probably just need 5. There we go. Okay, so here's one column. All the zeros are right here. So we're looking at one of these. So the important thing to note, right, I'm going to pull all the zeros and just operate on those first. So I'm going to temporarily grab a list item. That's this. Let me give this a little temporary color. Yellow feels pretty temporary, right? Okay. Yeah, me too. It's a terrible color. All right, so this is what we have. We have a list of these things, and then we also have a list of center points. That's what you see right here back in these frames. A frame is a point. It just happens to be a point that is tied to a particular work plane, right? A two-dimensional plane. So we can map vectors from this to each of our edge points. So let's go to curve. We'll go to vector. Actually, let's go to vector and let's do vector 2-point. Vector 2-point is going to go from a base point, which is the center point of my geometry, to the endpoint, which is this. So right now you don't see the vector unless you turn on vectors to see them, so I'm going to do that for your sake.
Under display, vector, vector display. Put the anchor point is these, and that's the vector. And this needs to be grafted. Whoa, that's not right. Hang on. Anchor point. So we have 20 vectors. Oh, this is going out in groups of 20. Why is that going out in groups of 20? So each one, oh, this can just be grafted. There we go. So that's what you're seeing right here, is that each one of these elements has a vector, and those vectors are what we're going to modify, because those vectors have what? Two things. Two things? Direction and magnitude. So that magnitude is going to be readily available for us. If we're looking at the vector, you can see that right now it's 19, right? And that also happens to occur back here. So the thing that we're gonna, the operation that we're gonna do here, really it's defined by you guys. So however clever you want to get with your math, that part's up to you. You could do a sine wave if you really want to get into the trig of it. And so all of those points, as they're coming down, are going to move a particular amount. So if you wanted to create a sine wave formula so that it's going to evenly go in and out like as it's going down, your sine wave is going to create something that, well, it's actually going to go sort of through that one and then back down here, right? So this is going out a certain amount and then in a certain amount. Does that make sense? Or you could just do it kind of random. So if you look at the example that we built, it actually is sort of random. So I'm going to assume that it actually is, and I'm going to let my numbers just kind of do the work for me. So when I have these vectors, I want to change them to something new, right? So the value is 19. But we want to change whether or not it's going to actually be 19, right? So we can go anywhere from maybe 17 to 21 or a little less. So let's kind of work backwards a little bit. So we're going to have to recreate vectors. So in order to do that, we're going to go to vector, not that. Amplitude, right? And we're going to modify that value. So if we go to vector length, it's going to return the length of each vector, right, in a number. So I'm doing this on purpose because even though right now all of them are going to be 19, that's not always the case, right? So this is the way you would want to do it. So this is creating a list that says a whole bunch of 19s, right? And we are going to modify that list with randomizers that are going to change the structure of that list. Like each one is going to be different. So let's so we have all the 19s. Let's go to how do we want to do this? We want to create a set of numbers and then jostle them around, I think. So let's go to let's do it with sequence. And let's say, I guess we could use series. Let's use series. So the series is going to have a first number in the series, and then it's going to have a step size, and then it's going to have a number of values, right? So that's important because we can set this up so that it has kind of a boundary based off of what we define is going to be the limitation for the system. So let's say our first number in the series is going to be 2 under what the maximum length is going to be, which is 19. So we can take that 19 and plug it in here and then just say -2. Sorry, the expression fell off screen. X minus 2. We can play around with this a little bit more too, but let's say the step size is going to be something pretty minuscule. So right now we're looking at, I think we have, what do we have? How many circles? So we also have 19 circles. let's just say that our step size is going to be, if we're going 2 under, we might want to go up to something like 4 max over. So our step size can be like a 0.2. Does that sound right? So 20 over 2, or 20 over 4. Yeah. 4 divided by 20. I'm really bad at simple arithmetic.
20 over 4 is 5.
4 divided by 20, though. 0.2. Yeah.
4 divided by 20.
So let's go to this, and we'll say 0.2. And then we have a count. So the count can be anything. It can be, the number that we were working with before. I think we're going to have to match that number. So we'll start here and just say it's going to be 19 numbers. So the numbers we come up with are anywhere sort of listed here. So what you need to know at this point, though, is that the lists don't match, right? The data that you're seeing here is different than the data that you're seeing, say, here. What's different? Well, no, not so much the numbers, but what's different about the data, right? Like the structure of the data.
One of them has 1, 2, 3 points.
No, I mean, one of them is flattened. The other one is grafted.
Okay.
You'll never get these two to speak to each other the proper way if you're trying to do an operation on individual items and you have a flattened list like this. Okay, so what we have to do is first reorder the list, then we want to graph the list, and I'll show you why. I'm going to leave it like this for now, and we're going to use this and we're going to graft it, right? So see how now we have data that sort of looks like that, right? Sort of matches. We have now 17, 17, 2, 17, 4, 17, 6, 17, 8, right? Instead of the 19s. So that's the objective here, is we're going to use that as our amplitude. Yeah?
So grafting gives a z-axis to it? Or?
No. Grafting only restructures the data. So what I had here, by now you guys should have, like, if you're at all not clear about what grafted and flattened is, then we really need to drill into that, because by now you all should have a full mastery of what grafting and flattening is.
I'm just confused what the right side is on the top one. It's like has 4 variables.
This?
0, 0, 0, 0. Yeah.
So that is how many operations have happened to that data, which means it's a different branch of a tree.
Oh, okay.
Yeah, so that doesn't have anything to do with the structure of the data. It just has to do with like how they communicate to each other. But anyway, so let's go back to this being grafted. Okay, so now we're operating with separate numbers. So when I use that value as my amplitude to replace these vectors, right, the new vector that we're going to be looking at is that. So we have some that have shortened, and we have some that have lengthened, right? But that's not what we want to do either, right?
But it's a start.
It's a start. It's close, right? But what we want to do is create it something that kind of like oscillates going in and out. We don't want it to always be, in this straight line.
Right.
So the place, where would you say is the place that we need to change our data? Like where would we maybe jitter it, and kind of shake it up? Right, at amplitude. Well, I had left my mouse there, I guess, subconsciously. But, yeah. But, I mean, technically, though, it's a little bit before that. It needs to happen before you graft the information. Do you understand why?
Well, yeah. Okay. Well, that's the next question. Why?
Does anyone know why? Okay. It has to happen before you graft it, because, like, it's kind of like putting it into boxes. And then shipping it out, right? So if we have, let's say we have a 17 and a 17.5 and an 18 and then an 18.5 and then a 19. Okay? Nice, neat list. It's all going in order. I need to graft those so that they will separately operate on each one of these vectors. Makes sense, right? Because that's what we just did. When I graft it,
these get separated into different lists.
Okay, so each one of those is a totally separate list.
Almost like, you know, like this. Okay, totally separate list. So now when they get pushed out and you try to randomize it, what's going to happen is, and you try to jostle it all up, it's going to take this one and it's going to say, okay, 17, let's jitter it up, let's shake it up. But the only thing that's in that bucket is the 17.
Right.
So it's not going to shake up. But each one of these items is going to keep its, so like you got to think of each of these as a separate list. It's a set within the list. So they're going to stay in order. But then each of these separate lists is going to get shaken up. But if there's only one item in there, you can't shake it up. So you have to shake it up before you break it apart, before you graft it. So let's take that off. Notice how now it's doing a whole bunch of these, right? 19 on every single one. So that's what happens when you try to not do it with a grafted element. So we're going to jitter the series first. So let's go to set and sequence jitter. Plug that in. And let's plug this into the data there. So it already has some information that's like preset. That's fine for me. It has a shuffle strength of 1.0, which means it's a full shuffle. And then the seed just changes what the actual shuffle variant is. So I'm fine with that as it is. I'm going to graph that. So now I've got a 19.2, 19.4, 18.8, 17.8, 17.4, 24. So let's go to there. Now we've got a different one for each, right? It's looking a little closer to this, is it not? Okay, so we have to take this information and then apply it to all of the sets, I guess you would say. But we need to kind of look at that data and make sure that it's still flowing the way we want it to flow. So let me get rid of some of this extra stuff. I'm going to leave the, let's do it this way, right? So we have the vector, and we need to actually move those points. So let's go to transform, Euclidean. We're going to say move, and we're going to move these points, and we're going to move it on this vector. Oh yeah, that's right. That's a little. That's right, because it's moving it by that amplitude, so it'll move it away. So we need to subtract a number from each of these. So we have we would want to subtract the 19 from each of these. So we take the same number that we had here. I'm going to replace this with an integer, or I mean a number, and just replace that connection there. And then I'm going to say math subtraction, and I'm going to say subtract from each of these numbers this. So now we're going to get a value that is a lot smaller, but it still shares the same delta, right? Some are going in, some are going out. So that just reduced the distance. There you go. See that? So what's cool about that is I can actually create a curve with these, but I need to restructure them. But we'll get there in a little bit. Let's turn that off a little bit too. Don't need vector length. Get rid of this. Okay. So I know we're kind of moving a lot on this. I've been lecturing you guys on it for 20 minutes now, but I want to pause real quick and see if you have any questions about this before I do the whole thing. And I'm going to do it all just in one video just to wrap it all up. So it shouldn't take much longer after this. No questions? All right, let's knock it out and then we'll take a break. So now we need to do the same operation on all of them. And it's going to look a little funny at first because the groupings and stuff might not always translate. Once you go from like one subset of data
and you try to move into many subsets of data, oftentimes what's going to happen is your grafting and your flattening aren't going to be synced up. We'll see if that's the case here. So really all I have to do is bypass this list with the connections that are there. Okay, but let's take a look at that list. The information that we have going into it is looks like this. Okay, and we pulled index 0. So what this is doing, if you look at the information, right, we have up top, index 0 is 7.9, 94.3, and 38.9, right? 38.9 shows right there. It's then taking the next 0, which is this one, and it's pulling that one aside, 7.9, 94.3, and 36.9, right? You see the same thing right there. So it's taking the first item of each of those lists. Let me set this aside for you so we can reference it later. So when we change that data and we start to look at it down the line, I'm going to first save in case anything gets crazy here. I'll just put it on my desktop for now, and this is put it in dump, and this will be, well, let's call it Peterson something. Save this too, not save small, save as, desktop, dump, Peterson. Okay, now we're safe. So I'm going to lock the solver here just in case this causes any issues. But effectively, I'm going to bypass this connection and reconnect these points into each of the vector 2 point and then the move. So I'll put that in that location, which overrides that connection, and then I'll also put it in move. Okay. Let me unlock that. Cool. So it looks like the data did, for the most part, stay packaged the way I want it to stay packaged. Okay, that's good. I actually didn't expect it to. So now when we look back at the new data that's being generated, it shares the same structure. So we have all 10 of the groups stayed grouped the whole way through. And it turned out actually quite well. So let's take this this element and let's kind of create some curves with it and see what it does. So let's go to under spline. Let's grab an interpolate curve. And the interpolate curve is going to ask you for a few things. It's going to ask you for the vertices, which is easy. That's just a list of points. And then it'll ask you for certain elements related to how that curve is going to look and calculate. So the curve degree is how accurate it's going to be, and then whether or not it's periodic, which I forget what that means precisely, and I don't know what knot style does. It shouldn't matter. Let's plug this in. Okay, so we've got an issue. All right, cool. I like this issue. So we've got an issue. Do you know what the issue is? Based off of what you're seeing on screen. Anybody?
The circle
What's that?
the circle looks perfect.
Well, I mean, that is the problem, is that they basically are circles.
Right.
Right? They're not going vertically down the list.
Right.
Okay, that's because when we created these points back here, these are 0, 1, 2, 3, so on and so forth around the top circle. So when it reconstructs that information, it goes from 0 to 1, 2, 3, so on and so forth around the top circle. So we need to restructure that so that now we're actually going to connect our interpolate curve from the 0 point of this list to the 0 point of the next list to the 0 point of the next list, so that it goes vertical instead. Which I'm hoping at this stage, because the data came through so clean, we can just use flip matrix. Do you know what flip matrix does?
No.
Okay, flip matrix is yeah. So like if I have let's say I have a grid.
and I split this grid into a couple of grid cells. So 1, or actually let's do it correct. So 0, 1, 2, and 3, and then 0, 1, 2, and 3. So those are columns, right? And if you use a certain grid type tool, it's going to organize it in columns for you. It's going to say 0, 1, 2, and 3, and then 0, 1, 2, and 3. And you can select this column and then select this column separately. Flip matrix simply revises the order of that list so that instead of that, you actually have 0 and 1, and 0 and 1. So this is going to be 0 and 1, 0 and 1, 0 and 1, 0 and 1. So that now you're collecting rows instead of columns.
Oh, I see.
Make sense?
Yeah.
So I hope it'll work here. Sometimes it doesn't. So let's go, flip matrix is under sets and tree. So I'm going to plug in flip matrix and let's just do a quick little data test. So if this works, then I should have an 8.1, 94.3, 38.9, and then followed up underneath that I should have an 8.3, 94.3, and 36.9. Which I do. So that looks right. So now let's take the flip matrix and we'll plug it into B. And those are your curves. So now what's neat about that is we can sort of solidify it the same way that we did in the last exercise. So we'll go to freeform, we'll do a loft, plug that in. I don't know why it doesn't want to loft those. It should. That's weird. Why won't that one work?
What if you just apply a surface?
I don't know. That one's odd. It looks like it's oh, because I see. Flatten. There you go. Okay, so it's kind of close here, but the problem is all the numbers are the same. Okay, so final thoughts on this is that if we want to go back and revise it so that it matches like the randomizer, right, we need to now reorganize the data again, right? We need to jitter it, but we need to jitter it in a different place because now it's being jittered and then it's being fed to every single list again in exactly the same order, right? Okay. So let's go back and diagnose that. So here's the jitter, and here's the new input we have, okay? This new input is that value, okay? And then the information gets fed back into vectors that look like this. We can change those vectors. Though I'm not sure if it'll do it in every order again. So let's try, how do I want to do this? We can flatten it, jitter them all. So we can flatten this whole list, jitter every single one of them, and then re-break it apart in groups of 10, which I'm going to do. So let's see, our series right there says series of 19. That's not what we want. We want 19, but these are groups of 10. All right, let's do this. I'm going to go to, that's a vector, right? So let's grab geometry, and let's flatten this. So now all these vectors are reading as one giant list. I'm going to jitter those. Okay. And
But you still gotta keep the
then well, then I just need to break it apart again. So this is getting grafted into individual items, so I don't want that. I want to take those numbers and I want to break them into groups of 10. So 19 separate groups. So we can go to set list and let's do partition. And we're going to take our list length. Let's see, our list length, because we have 200 items and we want them in groups of 10. So we do the list. Yeah, okay. So let's do it this way. We have, where are we here? 19 items down here. So we're going to take that 19. We're going to say 19 plus 1, right? Because that's how many. We talked about it before, right? Like every once in a while when you're breaking apart, like grids, for instance, and you have multiple points, and you're always going to have that one remaining extra that you need to account for at corners and stuff like that. So I'll illustrate what I mean. So we have 1, 2, 3, 4 cells, but if you look at the points at each of the cells, we have 0, 1, 2, 3, 4, or 5 points. Same concept. We have 19 lists, but we need to divide it by 20 to get the divide it by 20 to get the 19 lists. Yeah, because it's an index value of 19, which means 20 separate lists. So that is for partition. We need to create a size of the partition. So we're going to take this number, same one as this, it's 19. Let me just go down here actually. That plus 1.
So you don't really need those math operators anymore.
Go like that.
Go ahead and right click on the actual node. And
Yeah, I'm doing it rapid now because like before when I was doing the definitions, guys, I was throwing in like all the mathematical operators so you can visually see it.
Right.
Now, like every once in a while, I'll kind of take the shortcut, clean it up a little bit.
That's excellent.
So now we've got lists that are partitioned. We have 20 separate lists, which are grouped in groups of, oh, it's not. 20 items. So we need, so not divided by 20, so it's 2. We need it divided by 10. Where did I get that? So it's groups of 200. And because I'm trying to make it smart, so if I change the numbers, so I don't have any static numbers that I need to go back and change again. So we have groups of 20, well, groups of 19. Why is that 10? Oh, no, this should be right. This should be right. Because there's a different count in that direction. So let's put, that's a jittered vectors. Okay, so it only jittered some. Oh, I see. Hang on. I think I kind of get what was going wrong. So this geometry, so this actually is grouped up in groups of 10, so I think that's what we need. But where do I pull the 10 from? Because I want to make sure it's smart, right? So I want to make sure that it comes out in groups of 10. So let's do it this way. This vector, rather than pulling from the overall number of splits, I'm going to pull from the list of vectors, but I'm going to grab my first item only. See that? So now, well, no, I can't do that. I need to explode it. Tree, explode tree. That's what I'll do. So when you do explode tree, then you get lists of 10. Okay? I know I'm losing some of you guys, but you're going to want to go back and watch this again, I promise. So you get groups of 10, and then you can do your list length on that. Boom. Take off this expression. We're almost there, guys. Commit the changes. We're there. And we'll plug this back in. Boom. There it is. We did it. Thank you. Thank you. It only took 35 minutes. So it looks a little like floppy and silly. I know that it's not exactly what the other one was, but maybe let's put it on rendered view.
Dude, that is awesome.
So we got close, you know, and you can change the values so that it looks like something similar to what you'd actually want.
That's pretty good.
Yeah.
Fuck that. That's really good.
Satisfactory? Okay. All right, let's take a break. A well-needed, you know, and deserved break because you guys are just sitting there doing nothing while I'm up here having all the fun. So I'll give you guys 15 minutes.